Good day everyone, welcome to our session today. I'm going to summarize what we had discussed so far on the solvable groups of trigonometric integrals. So last time we talked about this topic, no? We have solvable groups of trigonometric integrals. Then we have group 1 integrals of the form integral of sine u to the m times cosine u to the n du, and we have the integral of sine u to the m du and integral of cosine u to the n du, where m and n or n are positive integers. And then we have three cases, so we solve three cases here. Case 1, then we solve this example, okay, and then we have case 2, and then I give you this example. I solve this problem. Then we have case 3, alright, and we have this example also. Then after that we had discussed group 2 integrals of the form integral of tangent u to the m times secant u to the n du, and we have also the form integral of tangent u to the m du and integral of secant u to the n du. And then we also have cases here where m and n, or where m and or n are positive integers. So case 1, we have this case 1 when m is odd. We have the rule to factor out secant u tangent u du, then change the remaining tangent into secant using the identity tangent squared u equal to secant squared u minus 1. And then we have solved this problem, okay. And then we have case 2, alright. So we have this case 2, then we solve this problem. Then we have case 3, okay. So for case 3, we have when m is even and the integrand is tangent only, so we have to use the identity tangents squared u equal to secant squared u minus 1. So we solved that problem also. So today class, just to summarize also group number 3, so integrals of the form, okay, so we have this cotangent u to the m times cosecant u to the n du, and integral of cotangent u to the m du and cosecant u to the n du, where m and or n are positive integers. So the rules here class, or the way to solve problems that involves this form actually is almost similar or very the same on the things that we did in group number 2. Okay, so if you look at case 1, so if you look at case 1, cosecant when m is odd, then we have to factor cosecant u cotangent u du, where in the previous group number 2, so we have tangent, we have secant u tangent u du, combination of secant u tangent u du. But this time, so we have this time class, we have to factor out, we have to factor out this cosecant u cotangent u du. So this is case 1 for group number 3. In case 1 of group number 2, so this is secant u tangent u du. Alright, for group number 3, so we have to change the remaining cotangent into cosecant using this identity. Cotangent squared u equal to cotangent squared u equal to cosecant squared u minus 1. Alright, so that is for case 1. And then for case 2, so when n is even and greater than 2, n, take note class, as n is the exponent of cosecant, alright, m is the exponent of cotangent. So when n is even, meaning the exponent of cosecant is even and greater than 2, then we have to factor cosecant squared u du, and then we have to replace the remaining cosecant by cotangent using the identity, this identity, cosecant squared u equal to cotangent squared u plus 1. So that's case 2. So if you look at this or compare this case for group number 2. So it's very similar, class, right? So in group number 2, case 2, this is secant. So we have to factor secant squared u du. But here in group number 3, case 2, so cosecant squared u du, we have to factor this out. Okay, and then we use this identity. Then for case 3, so for case 3, when m is even and the integrand is cotangent only, so if you compare this case in group number 2, so it says in group number 2 when m is even and the integrand is tangent only. But here in group 3, case 3 is when m is even and the integrand is cotangent only. So in this case, we have to use the identity cotangent squared u equal to cosecant squared u minus 1. Okay, so I'll just give you one example for this case, and the rest you need to practice yourselves. So there are a lot of exercises in our references, so you may find them there, and then you try to practice, class. You just select example that is similar to group number 2, case 2, and then try to use this concept to solve that integral, and so do with this one. Okay, so in our next video, I will show you the solution for this example. Alright, so see you in our next video. Bye.